part 2 of the CAD tutorials. So I'm going to assume that you watched part 1 of the tutorial and you know how to set up a new milling operation and you know the basics of setting up all the geometry, your stock material and your coordinate system. So I'm basically just going to run through the actual generation of the milling that we need to generate this part. So the first thing we've done is I've set up my tool database. We're using 3 tools here. So the first one is a 6mm end mill. The second one is a 10mm end mill. And the third is actually a 6mm ball nose end mill. So the ball nose end mill is what we're going to use to generate this spherical component here. So we've got our 3 tools set up. The first procedure that we've generated is this spherical component. So if we select geometry, define, I've used work on the selected face here, and I've selected this spherical component. The next step is I've defined what tool we're going to use. So we've used the 6mm ball nose end mill. The levels, upper level being 0, which is the top of our stock material, and the lower level being 28mm from the top, which is the edge of this spherical ball. The method I've used is contour. So contour because we're creating a ball here and we're going to work from inside out to create this spherical component. The step down I've used is 0.25. This is to eliminate any surface roughness or imperfections on this ball. In the real world, you would probably want to go even smaller, maybe a 0.1 step down. It just makes this surface finish of the ball a lot nicer. So we can calculate this. You can see it takes a lot longer to generate that. And here's our toolpath. So you can see it's super in depth because of all those steps and like micro movements of the tool. So we can simulate this and speed it up very quickly to see what it's going to do. You can see it's just working away around this ball. And you can have a look at our rest material once the procedure is completed. You can see we've created that ball. And if you were to do a larger step, you can see those steps there in the model. If you were to do a normal 1 mil step, those steps would be a lot larger and basically you wouldn't have a spherical ball. So the 0.1 step down in the real world is a lot nicer. So the next milling procedure I added was to generate all of this components here, these blocks and through holes. So first step was define the geometry. I've used working area. And you can see I've selected this edge here, which is in line with this outer edge as the upper level, and the bottom surface here or face here as the lower level. So it's going to machine everything in between these 2 levels. So it's going to create all of these components all the way down to the through hole. So the tool we've used is the 6mm end mill. I've selected 6 because some of these smaller slots here and the holes, it's just nicer to do a 6mm end mill, and some of the geometry and surface finishes would make it a lot easier with the 6mm instead of going straight to the 10mm. Levels, I've selected the upper level at 0, and the lower level I've selected as the bottom of the stock material. So this will allow it to go all the way through for the through holes. Technology, I've used hatch and a step down of 5mm. Because we're going down 44mm, if you were to step down, say 2 or 3 mil, it's going to take a long time. So the step down of 5 is pretty suitable for this application. So we can have a look at the simulation of the calculation that it's done. And you can see here, this is its procedure. So it's going to mill everything down from that top layer all the way down to those through holes. And we can have a look at the material afterwards, the procedure. And you can see here, we've got our central components, and all that's left to do is machine these outer edges from the stock material. So for the final operation, we can have a look here. The geometry we've used select on faces, and we've selected these 2 outer faces of our part. The tool we've selected is the 10mm end mill. Sorry, the 6mm end mill. Again, it's just nicer to follow that radius around with the smaller tool. You can use a larger tool, but I've just used the 6mm in this case. Levels, upper level again, set to the top of the stock, lower level to the bottom of the stock, so we can remove all the material. Technology, I've used contour just to wrap around the part in a nice way, rather than going across, then all the way down, across. Step down to 5mm, again, because we're going 44mm down from the top full, it just makes sense to step down 5mm. We can save and exit. Have a look at the simulation that it's done. So you can see here, it's going to work its way around the whole part until it removes all of that stock material. As you can see here, it's removed our part from the stock material and we've got our leftover part here in the middle. So to generate this code, G-code, generate, name it what do you want, let's call it part 2, okay. It's going to generate all of the G-code, and here we are. We can go file, save as, save this to where we want our G-code to be saved, and there you go, that's the G-code generated for part 2. Thanks for listening.